In this video, we're going to bake the Harness self-managed platform into a Kubernetes cluster. The Harness self-managed platform allows customers to host the Harness platform themselves as an alternative to the SaaS option. The underlying infrastructure is going to be a Kubernetes cluster, and with Kubernetes, anything goes. It can be on-premise, GKE, EKS, AKS, doesn't matter. As we are using Helm to control the Kubernetes resources and the whole deployment is going to be based on Helm charts, we will need the Helm CLI being installed alongside access to a terminal with kubectl. First off, let's get that cluster up and running. For the cluster creation, I'm going to use GCP to spin up a GKE cluster. I'm going to use really basic configuration. I'm just going to give it a name. And then just select the instance type that I want. I want 3 nodes. Let's have a look. Let's select E2 standard. Go ahead and create that. While we are waiting for the cluster, let's download the Helm charts. For the Harness Helm charts, we can navigate to the Harness Helm charts Git repo and download the latest release. So now that we are waiting for the cluster to come up, it's time to pick up the overrides and finish the configuration in parallel. In this example, I'm going to use the basic configuration settings, but obviously you could have additional settings, especially if you're working in an isolated environment and you want to do an air-gap installation. So first things first, I need to define my load balancer URL. That should be really straightforward to do. I'm going to add in the URL here. For the load balancer URL, I'm using a domain that I acquired from a third party that is pointing to the Kubernetes cluster endpoint. Typically, AWS, GCP, and Azure will have the option to generate a domain when you create the cluster. And if it's on-premise, you can use any of the internal domains or even an IP address. I'm going to leave everything else default, and then I'm going to have to select the Harness modules that I want to include. So let's go in and select CD. Let's put in CI, and let's progress further down. Let's leave everything else default. And the last item I'm going to set up is the networking. So Istio is going to be disabled, as I'm not using Istio for this example. Nginx is going to be set to true. Keep that as it is. Just need to add the host name. That's pretty much the same as the load balancer. This will be used to create the ingress rules. I want to create an Nginx controller. If you have the Nginx controller already in the cluster, you don't have to do that. Just make sure that when you select the class, matches the class of your Nginx controller. Everything else, resources and stuff, I'm going to leave that to default. Our cluster should be up and running, so let's validate that. I'm going to use the terminal to run a kubectl command to get the nodes. And I can see all my nodes are available in a ready status. So I can go ahead and start deploying the Harness platform. First thing I want to do is create a namespace. Platform to be isolated. And then run the helm install command to install the Harness platform. So I'm going to give it a name. This name is going to be used later on to run upgrades or delete if I want to delete. I'm going to select the downloaded Helm chart, point it to the right namespace, and then use the overrides we created earlier. Helm now is going to start deploying all the components and all the required Kubernetes objects. We can see the activity that's happening on the namespace. We can see all the new pods are being created right now. We're going to give it 5 to 10 minutes and come back when everything is up and running. So now that the pods are up and running, the application is also up and running. All the networking is done automatically with the Nginx controller that we deployed. So we should be able to navigate to the load balancer URL, and that will result into the Harness login page. As this is a clean SMP installation, we won't have a user yet, but Harness gives you the ability to define a new user. Just need to navigate to the sign up endpoint where you can define the new user here. I've created my user and we can then log into it. So now that we are logged into the platform, we can see that the platform is empty. We don't have any projects as that's a clean installation, and we could start creating projects. One last item before we complete the installation fully is to make sure that we can invite other users. And for that, we can go into account resources and create an SMTP server that will allow us to send invitation emails and forgotten password emails to users. So that gives you flexibility to invite users. Or you can go into the authentication and use auth providers, summer providers, or LDAP to synchronize with another authentication mechanism. That would complete this demonstration with a fully self-managed platform installed into a Kubernetes cluster.